Hey guys, how's it going? It's Ben from Chegg Tutors here, and today we'll be covering the statistics concept of predicted values using regression equations, or more colloquially known as y-hats. So, in this video, we're going to define what y-hats are, then we're going to walk through a few examples to familiarize you guys with using these kinds of ideas for problems you might see in your classes. So, let's start off with the definition. So, y-hats, or predictive values using the regression equation, are values that you get from using the regression line that you get from your data set. So, looking at this plot here, you guys might be familiar with the least square regression line, or some other form of regression line that you can use or draw based on the points in your data set. That gives you an approximation of what the relationship between your two variables. So let's say this is x, this is y. So this line gives you a rough approximate relationship of 0.5x plus 2. So that's your line over here. So the slope is 0.25 and the y-intercept is 2. You guys know this. So the y-hat, so the reason why it's not y in the equation, so over here is our general equation of a regression line. So the reason why it's y-hat and not y is because y-hat represents the predicted y value. So the difference between y-hat and y is the y is supposed to be the actual y value of your whatever you're looking at, whereas the y-hat is what your regression equation that is given to you is going to predict the value is going to be. So you might be wondering, since I already have these data points, why would I need to predict any y values? Well, the reason that you draw these regression equations and the reason that you would use these y-hats is because you want to predict the y values based on x values that you don't have the y values for. So, for example, if we look in this plot, we only have 4 points. So usually it's more than this, but it's just an example. So let's say that we wanted to estimate what the y value would be for an x value that's, I don't know, say around here. So an x value of here, we actually don't have a data point that really corresponds to this x value. So the next best thing that we have is the predicted y value that our equation would give us. So hopefully that makes sense why you would even bother to use this y-hat concept. So let's do a quick and easy example. Let's use our plot here. And let's say that let's say that our experiment is we're trying to determine what the correlation between, let's say x is equal to hours in the sun. It's a really bad hours. Also a really bad sun. Hours in the sun. Okay. And y equals height in inches. And let's say that we have some, I don't know, like potted plants, and we're doing some beginner's experiment of how varying the hours in the sun that you let it grow in affects your height, your final height of your plant. So let's say that you had 4 plants, you plot these 4 points, you got this regression line, and you say that, for every 1 hour extra hour in the sun that you give it, it grows an extra 0.25 inches. And alright, that's cool. So let's say that you had a value over here. Let's say this is, 4 hours in the sun. So you don't have a data point that corresponds to 4 hours in the sun, but you do have this regression equation, this handy-dandy regression equation that you just calculated. So you can use this to predict, based on your other data points that you collected, what the height of the plant would be if you let it have 4 hours in the sun. So this is simple plug and chug. So your y-hat is going to be equal to 0.25. You just plug in the x value, which in this case is 4 hours, and you get 3. So 3 inches. So that's your y-hat. That's your predicted value. Pretty simple. Okay, so this is the simplest kind of question they can ask you. A more common concept that they associate, or that statistics professors associate with y-hats and predicted y values, is the concept of, let me draw it out. Yeah, over here. So let's see. This is called a residual. So the concept of residual or delta y, is the difference between the actual y value of a data point and the predicted y value. So, for example, for this data point number 2 over here, the residual of it would be equal to its actual y value, which is over here, and the predicted y value, which you can get by just following the x value of the point down until it hits your regression line, and that y value at the regression line would be your predicted value. So, your delta y is equal to your actual y minus your y hat. Because here, this is your actual y, and your y hat is going to be over here. So that's what your regression line predicts based on that x. So, you need to know what this y hat is, or how to calculate it, in order to calculate this residual. So, a positive residual implies that the data point is above your regression line, because your actual y is going to be larger than your predicted y. And a negative residual, is, you guessed it, means that your data point is going to be below your regression line. And this is because your actual y value is going to be less than your y hat. So let's say this one, for example, this point over here, the residual is pretty small, but it is negative, because you're going to take your actual y, which is over here, which is less than the predicted y, and so subtracting your predicted y from your actual y is going to give you a negative value. So those are some basic attributes about residuals. So the larger your residual is in magnitude, the further away it is from your regression line. The smaller it is, the closer it is to the regression line. So let's calculate a residual using the information that we've talked about so far. So let's just use the same example problem, and this time let's say that we have a plant over here. So let's say this is 6 hours. And let's say that the problem says you have a plant that grows at 6 hours in the sun, and you measure the height, and it ends up to be 5 inches. So you want to know how this compares to your previous data, and how it compares to the prediction given by your previous regression line. So it asks you to calculate the residual between the y value of your point and the y value predicted by your regression line. So in order to do this, first we have to calculate our y hat. So we do this simply by plugging in our x of 6 hours. So 6 times 0.25, that will give us 1.5. So overall, our regression equation predicts that, if you let it grow for 6 hours in the sun, if you let a plant grow for 6 hours in the sun, it's going to be 3.5 inches tall at the end. So now we can use our residual equation to calculate the residual associated with this data point. Oh, I didn't even draw the data point. It's just going to look something like this. So let's make it red. It's going to be pretty high, so like over here. So as you can see, the residual is going to be positive, and it's going to be pretty big compared to the other ones. So let's calculate our residual down here. So our delta y is equal to our y, which remember is our actual y values. Our actual y value is given to us. It's 5 inches. So 5 minus our y hat, which is our predicted y value, so 3.5. So our residual is going to equal 1.5 inches. And that's going to be the value of the difference in height between this point and the line. So 1.5 inches. So this lets you say that the prediction based on the regression line was off by 1.5 inches. And that's how you can apply residuals to word problems involving plots, x and y plots. So those are the basic characteristics and applications of residuals and y hats, and I hope that this concept is clear now.